What is up, young chemists? Mr. Rosen here. Today we're going to show one way to collect a sample of gas over water. So one thing we're going to do is record the temperature in the room, and I've let this sit for a bit, a little over 19 degrees Celsius, 19.2 degrees Celsius. So there's a spot in your data table for the temperature. You can record that as the temperature. The setup here is, this is the lighter, and I have removed the flint and wheel, and so all we're left with is this, which if you listen, maybe a little too quiet, but you can hear a tss, tss noise when I open this, and out of this opening, gas comes out. Now, if you look inside the lighter, it's a little hard to see, but there's a liquid in there. Now, the liquid is butane. However, if you notice, it's liquid inside and it's gas coming out. And if you ever wonder why that is, it's because it's under pressure. This container is under pressure. I don't know if you've ever done this, but if a lighter ever hits the ground really hard, sometimes the lighter breaks, and when it does, it goes pop. And there's no liquid. All of the liquid inside turns into a gas when the pressure lowers. So it's liquid in here because it's under pressure, but when you open the valve, it comes out as a gas. And we have a scale. Now, I am going to be taking this rubber tubing and attaching it to the end of this, so that when I push the button, the gas that comes out will run through the tube and come out the other end. Now, the other component of this is our trough of water, and I have this graduated cylinder here. So I'm going to take the graduated cylinder, and I'll just do this right now so that you can see it, and I am going to submerge it in the water, and I'm going to do it in a way so that all of the air bubbles, all of the air leaves the graduated cylinder. So there isn't, well, I guess it looks like there's one little bubble in there, but you want to have no air in the cylinder. It's totally underwater right now. And then I'm going to invert it. So the open end of the cylinder is going to stay underwater. And then I lift the cylinder up, and I can actually just probably leave it like this. And what you'll see is it's full of water. Okay, the cylinder is full of water. Now, I'm going to run the end of the tube that's not attached to the lighter, I'm going to run it down into the water and then up so that the opening is inside of the graduated cylinder. And this way, when I press the button on the lighter, the gas will move through the tube, and then when it comes out the other end of the tube, it will, the gas bubbles will rise up in the cylinder, and any gas that's collected in the cylinder, that water will be displaced just into the trough below. And because this graduated cylinder is, like the name implies, graduated, has markings on it, I can read the volume of gas that's collected. So this is one way to collect a gas over water. This is our setup. And I will put the camera down and run the gas in a second, but one piece of data that you need is the mass of the lighter beforehand. And this is going to be our scale, which goes out to 1,000th of a gram. So it's a pretty good level of precision. I'm going to put the lighter on the scale. Okay, lighter's on the scale. 16.642 grams. That's in grams. 16.642. Record that in your data table. The other thing that we can take a moment to do is, in the data table, it asks for the vapor pressure of water at the temperature of the room. And our room temperature was, I think we said 19.2 degrees Celsius, correct? Something like that. So this is our pressure, and that's in torr. So you can write that down. 19.2 is the temperature, and it's 16.685 torr. We'll be doing some conversions with that later. Okay. So I am going to set up the tubing, and this might take just a second. Here's the lighter. I'm attaching the tubing to it. And it gets a real nice snug fit on there. I'm then going to run this tube under the water and up into the graduated cylinder. Okay. And now I'm going to press this button. Here we go. 1, 2, 3. And hopefully you can see the gas bubbles that are coming out of the tubing are going up into the graduated cylinder. And as the gas bubbles go up into the cylinder, they have nowhere to go but the top, and the water that was at the top of the cylinder is just getting displaced out the bottom into the trough. And because this has marks on it, we're going to be able to read the volume of gas that we collected at our current atmospheric pressure, which in your data table, it says atmospheric pressure. We're going to use 1 atmosphere. So you can say 1.00 atmospheres. We're very close to sea level. On a clear day, it should be really close to 1 atmosphere. We're going to treat the atmospheric pressure as 1, and we have our room temperature, 19.2 degrees Celsius. We have our vapor pressure of water as well. We have a starting mass of the lighter, and we're going to collect some volume of gas here, and then we're going to measure the lighter afterwards. And I'm making sure to keep the lighter dry. Collect gas for a little bit more. We're doing this on such a small scale that our numbers, it's not going to work out perfectly, but we'll be able to use the data and do a calculation and see how you would calculate the molar mass of the gas by doing this, which is the ultimate goal. Okay, so I'm about ready to stop, and I'll stop here. We're gonna get a reading of the water, reading of the meniscus here. I have to move the camera, sorry. So the numbers are upside down, but it's between 40 and 50, and those are milliliters. I'm going to, it's having a little bit of a hard time focusing, but if I keep it level and try to get a good reading, 45, 46, we'll call it 47.0 milliliters, 47 milliliters. I'm gonna put this back. 47 milliliters, and then I'm going to detach this. Okay, detached it, and I'm actually just going to let this sit right here. The gas won't escape, it's just gonna hang out there. But now, keeping this dry, we're going to weigh it, and we're going to find the mass of the lighter afterwards. You can predict, do you think it's going to be heavier or lighter? No pun intended. Oh, snap, dad jokes. Okay, and the mass afterwards is 16.490. We'll go with that, 16.490. Okay, so we have a mass of the lighter before and afterwards. We know the temperature in the room, we know the pressure in the room, we know the vapor pressure of water at this temperature, and we collected the gas, and the volume of it was approximately 47 milliliters. Now, if we wanted to, we could, if you provided a spark, this would provide a very exothermic reaction, of course, but we're just going to let it let it all diffuse throughout the room. But with that data, you're going to be able to calculate the molar mass of whatever the gas in here was. And I told you it was butane, but if you didn't know, you could calculate the molar mass using that data. Think about it based on the data you have. Go ahead and give it a shot. Molar mass of a gas.